Hi everyone, and welcome to our group project presentation which revolves around PVT analysis. Before we dive deeper into the presentation, allow us to introduce ourselves. Hi, I'm Thierry.
Hi, my name is Iqbal Amir.
Hi, I'm Hannah.
Hi, I am Abigail.
Hello, my name is Adam Harris.
And we are Group 5 from Session 1. In this video, we will explore what PVT analysis is and why it matters, the key concepts and tests used in PVT labs, what we observed during our lab visit, our analysis of the given PVT report, and what we've learned from this project. Alright, so let's begin with a little overview regarding PVT. PVT stands for pressure, volume, temperature. It's all about understanding how reservoir fluids behave under different conditions. This info is key for reserves estimation, surface facility design, and reservoir simulation. A few terms you'll hear throughout. Bubble point pressure, where gas first comes out of oil. Next one is the oil formation volume factor, or BO, which shows how much oil shrinks from reservoir to surface. And then the next one is the solution gas oil ratio, RS, which is how much gas stays dissolved at given pressure, and other parameters which includes compressibility and viscosity. They tell us how fluid respond to pressure changes, as well as the Z factor, a correction for how real gas deviates from ideal behavior. Now, how do we get PVT data? We start with fluid sampling. Bottom hole samples are most accurate, especially if taken from above bubble point. Next, separator samples, which combines oil and gas after surface separation. Then last but not least, wellhead sample. It is a low-cost method, but it is also less ideal because it's only used for a special case, which is under saturated systems only. And then we go to the lab. We use 3 key tests. The first one is flash vaporization for conditions above bubble point. Next, we have differential liberation, which is for below bubble point, and gas is removed stage by stage. And then we have the separator test, which is to find the best surface conditions for oil and gas separation. From these tests, we get the real behavior of the reservoir fluid.
Alright, so now I will be doing a full analysis on the first sample, which is sample RCL 101-33559. So the first step will be to determine its bubble point pressure. So from the PVT report analysis, there is given a table with various pressure ranges from 2000 to 3000 plus with its different volumes. So from the values given in the table, we can make 2 different graphs of pressure against volume, and we can find its intersection between those 2 graphs, where the intersection would be the value of bubble point pressure, which in this case for sample 1 is 2627 psia. So from the value, we can actually determine the other specific gravity values for bubble point pressure that is determined from Vasquez and Beck equation, and also the specific gravity from bubble point pressure determined using plug-in values. So after finding out the sample's bubble point pressure, we can further determine the sample's oil compressibility for pressures above bubble point and also pressures below the bubble point. So from the table that we made, there are currently 4 different ways to determine the oil compressibility of the sample. Based on the 4 different methods, we got 4 different sets of values where we can turn them into graphs of oil compressibility above bubble point pressure and also oil compressibility below bubble point pressure. So for the graphs for oil compressibility above bubble point pressure, it can be seen that from the values of correlation and plug-in, it is actually quite similar, giving out graphs which is quite similar in shape with little to no difference. So this is mainly due to the fact that for the values we got from correlation, we use the Vasquez and Bakes equation, which is also the same equation that is used in the plugin. That is why the graph will be similar. As for the values we got from the PVT calculated using PVT and from the PVT report analysis, it is quite different from the values that we got from correlations and plugins. So moving on with the sample, we were able to determine the BO, which is the all formation volume factor, and also the RS of the sample, and we got three different sets of values. For the first set, it will be the values we got from the experimental value, which is obtained from the PVT report itself. So the second set will be the values of BO and RS we got from manually calculating using the Excel plugin, and the third set will be the values we got from calculating manually using the Vasquez and Bakes equation. So from the values that we got from the table, we can continue to plot two different graphs, which is the graph of BO versus pressure, all formation volume factor versus pressure, and also RS versus pressure. So for the graphs of BO versus pressure, we can use the three different sets of values from experimental value, Excel plugin value, and also Vasquez and Bakes value. We can see that the three different shapes of graphs from the three different sets of values, it is actually quite similar with little to no difference at all. As well as the graph of RS versus pressure, we can also see that the shape, or I would say the graph itself, is quite similar with little to no difference at all for the three different sets of values and methods that we obtain.
Hi, I am Abigail. Now, we are going to analyze the second sample, which is RCL 1016973. Now, if we recall back in PVT report, we will run and collect data from these three tests, which are constant composition expansion (CCE), differential liberation (DL), and separator test. But before everything happens, we need to make sure the fluids or sample pass the quality check. So in this report fluid sample, we will determine its saturation pressure or bubble point pressure, where the first bubble formed after expand its fluid's volume. From the PVT report, the bubble point is located at pressure of 3086 psia. I try to compare this graph with what I get from Excel. There is slightly different in bubble point determination, where I get the value of 3078 psia.
For the CCE and differential liberation, I calculate the value of BO and RS above bubble point and also below bubble point. So I use this correlation to get this value. And now for the compressibility, for the CO from the PVT report, I get this one because this value was provided in PVT report, so I just copy. So for the correlation above bubble point, I use the correlation that provided, and below bubble point there's a different correlation. Then we plot the graph oil compressibility against pressure. So for this is the result. Below bubble point, this is the result. Now I want to compare BORS from the experimental value, plug-in, and Vasquez and Bakes. So for BO and RS, we just copy from the data that we get it. So for plug-in, I use plug-in in Microsoft Excel. So Vasquez and Bakes, I use another correlation that we have learned. So these are the results, and 3086 psia is the pressure at bubble point. So for BO and RS from experimental value, this graph looks like this. And then for BO and RS from plug-in. This graph looks like this. For BO and RS from whiskers and bags, this graph looks like this. Look, we know that it looks like the same pattern, but I have made overall to compare what's the difference. So for the comparison, BO against pressure, so we can see that there is a 2 data here, but actually there is 3. Why? Because BO, viscose and bags, and also plug-in is almost the same. That's why it collapses each other. So for BO, experimental value is slightly different. Okay, for the RS, look, it's also the same as BO, but it also have the slightly different here. So the RS and also RS plug-in is here. It collapsed again, but RS experimental value, for this value, it's same 694, but this value does not same with plug-in and also viscose and bags. And that's all from my analysis for sample 2. Thank you so much.
This project deepened our understanding of PVT behavior and its critical role in oil and gas engineering. It wasn't just about collecting numbers, we got to see how pressure, volume, and temperature data are used to model fluid flow, forecast production, and design surface facilities. We became familiar with key equipment used in industry standard testing, including the Vinci PVT cell, RDS 300 system, S600C visual cell, and the Vinci bottom hole sampler.
We saw how reservoir fluid samples are transferred into lab cells and stabilized at reservoir temperature and pressure. We also saw all the equipment used to conduct such an experiments. Proper handling and conditioning are important to preserve the sample's integrity. One key test we witnessed was the separator test. Oil was passed through 2-stage high pressure separator and a stock tank. From this, we learned how to determine separator BO, oil formation volume factor, and RS, solution gas oil ratio, which reflect from the shrinkage from reservoir to surface. We also gain insights into, first, the safety protocols for handling high pressure fluids. Second, the use of recombination ratios for surface samples. Third, how agitated lab cells had maintained equilibrium during tests.
We analyzed 2 reservoir fluid samples. Sample 1 had a bubble point of around 2,627 psia, with an API gravity of 44.2, indicating a lighter, less volatile oil. In contrast, Sample 2 had a higher bubble point at 3,086 psia and a lower API gravity of 40.8, showing it was a heavier and slightly more volatile oil. We observed how BO and RS stayed constant above the bubble point and decreased sharply below it, validating theoretical expectations. The results from differential liberation and compressibility tests aligned well with both plug-in and VNB correlations, enhancing our confidence in PVT modeling tools. Overall, this project connected theory to real-world application. We improved our data interpretation skills, gained experience with industry practices, and now better understand how PVT data influences production strategies and reservoir management.
The visit deepened our appreciation for the technical accuracy required to generate trustworthy PVT data.
Before we wrap up, we'd like to briefly share how we use AI tools to assist in the preparation of this project. While we handled the research, report analysis, and scripting ourselves, we use AI to help fine-tune and organize our ideas. So here's how AI supported us in the process.